Hello, my name is Thirananun Kriang. Today, I will show how to create state diagram. First, this is my student ID. And I will select the last 5 number is 30099 in decimal number, and I will change it to decimal number. My decimal number, my binary number is 0 1 1 1 0 1 0 1 and 1 0 0 1 and 0 0 1 1 in binary number, and in hexadecimal number there would be 7 5 9 and 3, and I will choose just the last 8 bit. So I just focus only the last 8 bit. Next, I will transfer binary number to state diagram. Let's see how I can create state diagram. For the first state, we will check my first state check about CH active low. So if it's received 0 or if it's active low, they will get to the next state. But if active high, it's back to this state. And in this state, we don't focus about my data, so I will replace my data to X. And if an output in this state is 0, and the next state check CS signal again, but this state check active high. So if it's active high, they will get to the next state. But if active low, they get to this state. To check again, and I will replace the unknown data to X. And let's focus my binary number. The first binary number is 1. So if I receive 1 in data, they can get to the next state. But if I receive 0, they back to the first state to check again. If I get 0, so this state check. So I replace this state to D1. and output would be 0. This state output would be 0 too. And the next state, if CS signal active high and data receive 0 in data, they can get to the next state. But if they receive 1 in data, they back to the first state. If they receive 1 in data, and if they receive 0 in CS signal, they would be back to this state. If they receive 0 in CS signal, and in this case we don't focus about data, so I will replace data to X. So if they can get to the next state, I will call this state is D2. So if in this state, if I receive 1 in CS signal and if I receive 0 in data, they can get to the next state. But if they receive 1 in data, they back to this state. They will back to this state. So if the CS signal in this state active low, they back to this state. And I don't focus about data, so I will replace it to X. And in this state, output is 0. Okay, and if they can get to the next state, I will replace the next state is D3. And if CS signal active high and they get 1 in data, they can get to the next state. But if CS signal active high but they receive 0 in data, they will back to this state. And if they receive 0 in CS signal, they will back to this state. And this state output is 0. Then if they get to the next state, I will replace this state is D4. And if CS signal active high and they receive 0 in data, they can get to the next state. But if CS signal active high and get 1 in data, they will back to this state. But if CS signal active low, they would get to this state. And we don't focus about data, so I will replace it to x. In this state, output still show 0, and then if they can get to the next state, I will call the next state is D5, and if the signal active high and they receive 0 in data, they can get to the next state. But if the signal active low, active high, and get 1 in data, they will back to this state. And if the signal active low, they would back to this state. And don't focus about data. In this state, output show 0. Then if they can get to the next state, I will replace this. This state is D6. If the signal active high and if they receive 1 in data, they can get to the next state. But if the signal active high but get 0 in data, they will back to this state. But if the signal active low, they would back to this state. And don't forget data. In this state, output still show 0. Next, if they can get to the next state, this state I will call D7. The state D7, if the signal active high and receive data 1, they can get to the next state. But if the signal active high but they get 0 in data, they will back to this state. But if the signal active low, they would back this state. In this state, data show 0, and then I complete all of my data. If they can complete all of data, so let's see how next state is this. The next state I will call it dx. So we'll complete all of data. This state should show 1 in output, and this state have loop to turn on the light. The loop, the output of loop is 1 and 0. They will change 1 and 0. If the signal active low, they change output 1 and 0 to turn on and turn off the light. And we don't forget about data because we complete all of data. And if the signal active high, this state view back to the first state. The loop have the same result. So if the last two states get active high in CS signal and don't forget data, they would back to this state. Now I complete my my state diagram. So next I will create the left box. So let's focus about how I can create a treatable. So I will the first I will replace all state, and I will call this state is S0, S1, S2, S3, S4, S5, S6, S7, S8, S9, and S10. Now I replace all state. And so let's start how can I create treatable. The treatable would be have present state, next state, and output. The present state have S0, S1, S2, S3, S4, S5, S6, S7, S8, S9, and S10. They have the same like this. And next state would have 0, 0, 0, 1, 1, 0, and 1, 1. I think I don't have more space, so can I change this to the next page of paper? Okay, let's continue. Focus about state diagram. The present state is S0. If they get 0 in, if CS signal active high, they can get to the next state. So let's focus the CS signal. I would call this is CS signal and this is data. Look again this the present state is CS signal, and if the CS signal active low, they can get to the next state. So this is active low and active low. They can get to the next state. The next state is the state S1. The state S1. So we don't focus about this state. We don't focus about data. So we just focus about CS signal only. And if they receive if the CS signal active high, if the S signal active high, they back to this state to check the CS signal again. So if active high, they back to the state S0 and S0. Output this state, the output in this state is 0. So output should be 0. And then focus about state 1, the state S1. If CS signal active low, they back to this state. So it's active low, they back to this state S1 and S1. But if CS signal active high, they can get to the next state. So they have two way when they get when CS signal active high. The first is they get CS signal active high and data is 1. They can get to the next state. So let's see how the CS signal active high and receive 1 in data, they can get to the next state is S2. But if CS signal active high but data receive 0, they back to the state S0. And this state output is 0. So the output is 0. I delete it. I change it again. Sorry. Okay. Let's continue. So the next state is the state S2. In state S2, if the CS signal active low, they back to this state. If CS signal active low, so let's see CS signal active low, they back to the state S1. And if CS signal active high, they have two way to get to the next state. The first is if CS signal active high and data receive 0, they can get to the state S3. But if CS signal active high and data receive 1, they back to the state S0. And this state output show 0. Okay, next. The state S3. Let's see. The state S3. If they receive 0, if they the CS signal active low, they back to the state S1. And if sorry, if CS signal active high and get 0 in data, they can get to the state S4. But if data receive 1, they back to the state S0. if they get 0 in data, they can get to the state S4. But if get 1 in data, they back to the state S0. Okay, and see this output in this state is 0. So I will write 0 in output. Then let's focus state. The next state is S4. The state S4, if they receive CS signal active low, they back to the state S1. And if CS signal active high and receive 1 in data, they can get to the state S5. And if they receive 0 in data, they back to the state S0. In this state, output shows 0. Okay, I will go faster. Next, state S5. State S5, if they get 0 in, if the C signal active low, they back to the state S1. But if C signal active high and get 0 in data, they can get to the state S6. But if get 1 in data, they back to the state S0. And output show 0. The state S6, if C signal active low, they get to the state S1. And if C signal active high and get 0 in data, they can get to the state S7. But if receive 1 in data, they back to the state S0. And output show 0. Next, if the state S7, if they receive 0 in the signal, they can they will back to the state S1. But if the C signal active high, they can if the signal active high and get 1 in data, they can get to the state S8. But if receive 0 in data, they back to the state S0 and output show 0. The state S8, if C signal active low, they back to the state S1. If C signal active high, they can get to the next state. If receive 1 in data, they can get to the state S9. And if receive 0 in data, they back to the state S0. The state S8, output show 0. The state S9, if so let's focus state S9. They have something special. In the state S9, if they get 0 in CS signal, if the CS signal active low, they can get to the state S10. So in this state, we don't focus about data. So if CS signal active low, they can get to the state S10. But if CS signal active high, they back to the first state called S0. And in this state, output show 1 to turn on the light. And focus about state S6, the loop for state S9. The S10, the state S10, if they receive if CS signal active low, they back to the state S9. But if receive 1, they back to the state S0. Now I complete my state diagram, but I will change to call state S1, S2, S0 to the binary number. I will change the state, the position again. Oh, I think I forgot something. In the state S10, output show 1, I show 0. And I will change to the binary number, the present state. They have S0, so I will call it 0. The binary number of 0 is 0, 0, 0. And next is 1, 2, 3, 4, 5, and 6. Next is 7, 8, 9, 10, 11, 12, 13, 14, and 15. And next state have 0, 0, 0, 1, 0, 2, 1, 0, and 1, 1. And the last is output. Okay, this is one focus, just focus about number. This is decimal number, so I will change to the binary number. This is 1, so the binary number is okay. Let's continue faster. copy output. So we will see this is because we just have only state 0 to state 10. The next is 11, 12, 13, 14, and 15 we don't have. So I will replace all to X. And output. Now we have the truth table. So the next is how to use flip-flop, and I will add another page. From this truth table, I will use the flip-flop to make my digital circuit. Okay, now I will copy it, this truth table. And I will use the flip-flop. And I use the flip-flop 4 piece. Okay. From the flip-flop, the first the flip-flop. Next. I don't have any space more. I will change the position. Okay, I think I should make it smaller. Oh my god. Okay. They still don't have space. think it's enough. Okay, let's continue. The last is D4. Okay, I used four D flip-flop. Okay, from the flip-flop, if I focus, the present state is the state 0, and focus just the flip-flop 0, 0. So the first, this is Q1, I think. So let's focus this. I will write the first is 0, in this is 0, and second is 0. The second the flip-flop is 0. The third the flip-flop, the next state is 0. The third is 0, and the last number is 1. So the last D flip-flop should be 1 in the 0, 0. Okay, they have concept like this, so I will continue it faster. And the last is 1. Next is they have 0, 0, 0 and 1. Okay. Okay, I think I have something better than this. It is like this: 0, 0, 0, 0, 0, 0, 0, and 1 and 1. So and the last 2 is 1 and 1. Next, they have 0, 0, 0, 0, 0, 0, 0, 0, and 0. So they have all 0. next is 0 0 0 0 0 0 0 1 and 0. Okay. And the last, they have 1 1 1 1 1 1 1 0 and 1. The next is 0 1. I will make it faster. So they have, the last is 1 and 1. 1 and 1. So the order is 0. And they, in this flip-flop, the next flip-flop, they have our 0. So I will write our 0. The second flip-flop. The third flip-flop have 1 in, they have 1 in the state 9, so I will write 1 in state 9. Oh, I think I have something wrong. Okay, no, it's right. That's correct. Okay, sorry. 1 in state 9 and the other state is 0. And the last, they have 1, all 1 and the state 9 have 0. So I will write 0 in state 9, and then the other state is 1. Next, focus about 1 1 0. The first flip-flop have all 0. So I will write all 0. The second flip-flop, they have 1 in state in state 3, 5 and 6. So they have 0 in state 3, 5 and 6. 1 in state 3, 5 and 6, and all the other state is 0. Next, the flip-flop number 4. The flip-flop number 4 have 1 in state 2, 6. They have 1 in state 2 and 6. And the order is 0. And oh, I think I had something wrong. Can I check again? It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, but I have I think I passed some state. Okay, so I will change it faster. I will change. Sorry for my mistake. Okay, now let's continue faster. So, the okay, I will focus the state 11 to state 15 first because we don't have state diagram. So I will change it. I will replace it to x 11, 12, 13, 14, and 15. All of report have the same result. Okay, I will continue it faster. Okay, from the concept when I explained before. Now I don't explain again, but I will write it faster. Okay, now I complete my state diagram, and from the state diagram I will choose min term to create the left box. For min term we just forgot about the data. We just forgot about one. The result is 1, so I will highlight the result is 1 in the first D flip-flop. They have 1, and the second have 1, like the third, and the last flip-flop 1. Okay, next I will write about min term. Okay, now let's forget about min term to forget about the 1. My first D flip-flop have I will continue is faster. Okay, they have Q2 and Q3, Q4 and Q5, Q4 and the CA signal and data, or Q1 and not Q3 and not Q4 and CA signal and data, or Q1 and Q4 and not CA signal, or Q1 and Q3 and not CA signal. So they have 12 AND gate and 3 OR gate. Okay, next flip-flop. The second flip-flop have not Q2 and Q3 and Q4 and CA signal and not data, or Q2 and not Q3 and not Q4 and CA signal and data, or Q2 and not Q3 and Q4 and CA signal and not data, or Q2 and Q3 and not Q4 and CA signal and not data. They have 16 AND gate and 3 OR gate. The next is the third flip-flop. Have not Q1 and not Q2 and not Q3 and Q4 and CS signal and data, or Q1 not Q1 and Q3 and Q4 not Q4 and CS signal and not data, or Q2 and not Q3 and Q4 and CS signal and not data, or Q1 and Q4 and CS signal, not CS signal. And in this flip-flop, we'll use 15 AND gate and 3 OR gate. The last flip-flop is the first flip-flop. The first flip-flop have not Q1 and not CS signal, or not Q1 and Q3 and not Q4 and not data, or Q2 and not Q3 not Q4 and data, or Q4 not Q4 and not CS signal, or Q1 and not Q3 and not Q4 and data. The last D flip-flop use 11 AND gate and 4 OR gate, and the output is one in state 9. So focus about output 1 in state 9, because state 9, the binary number of state 9 is the binary number of 9 is 1 0 0 and 1, so we will focus just number 1. So the output should be Q1 and Q4. So from midterm, we will have 54 AND gate, 54 and plus 1 AND gate, and use 13 OR gate. Now I complete about left box and how can I create a state diagram.